Welcome to Convergence. My name's Michael Doran. I'm a California attorney, and today we're going to talk about Hurricane Andrew. I have to say that I voted for Reagan. I'm 60 years old, so I actually did vote for Reagan. I voted for Bush Sr., but there was a big, the climate change debate really changed my mind about anti-science, and probably no one in particular, no one more in particular than Rush Limbaugh. And Rush used to say that carbonation from volcanoes is what mattered, and he was talking about volcanoes for carbon dioxide. And at that time I was a warmer, and I thought it was one of the dumbest things I've ever heard. Because to me it was common sense that when you take something outside of the active biosphere and you pump it into the active biosphere, that's profound. And a volcano was just kind of part of the natural cycling of things. Well, convergence has occurred. And as I begin every show, I'm going to do it again. Albert Einstein said among the most difficult problems in all of physics is the Earth's magnetic field. I believe it's the most difficult problem in all of biosphere. And if you think about what volcanoes really spew out, that's interesting. It's sulfur. And in fact, if you look at the oldest forms of life, you have methonogens, you have bacteria, and then you also have sulfur-loving bacteria. Basically bacteria that will exist by vents of volcanoes, hot spots, hot springs, and to make use of the sulfur and the energy and the heat from the vents and create living conditions for themselves. And this has been going on a long time. Well, in 1991, there was a big volcano eruption called Mount Pinatubo, and it was 1991. It erupted for like 6 months of 91 and filled the air with sulfur acids. So the upper atmosphere was full of tiny little particles of sulfur, and that sulfur got dissolved in aerosols around the world. What I'm suggesting is just like carbon dioxide is an acid, life, DNA, RNA, the rudiments of life are acids, DN acid, RN acid, that sulfur acids got into aerosols, and in the context of large-scale, low-frequency undulations, cooled the planet. It wasn't just cooling in terms of a greenhouse gas effect, but rather what it had to do with microphysics and about the cloud processes, how clouds compress air, and how winds blow certain surface areas, colder water or warmer water. So it's a dynamic, not just a static thing, and how infrared energy is released out into space. And I also believe that the 500-year El Nino, 97-98, was the feedback result of that. So, for instance, you have cooling of the oceans, you have upwelling of cold, nutrient-rich waters, and then you get, in that cold, nutrient-rich waters in the tropic, you get higher carbonation. Then the higher carbonation gets into clouds, creates more cirrus, that traps heat, and eventually the pattern becomes one that warms. The pattern becomes one with an unusual amount of heating of the oceans and an El Nino. So Pinatubo is a very unique event. There was a massive injection of a lot of stuff into the atmosphere, but of most interest was sulfur and sulfur acids. Well, that is our lead up to Hurricane Andrew. Hurricane Andrew occurred the following year in the context of these cool down oceans. And Hurricane Andrew started a little bit later in the season, like compared to, say, what we've been seeing lately. It was an A storm. It was the first storm of the season, and it didn't occur until mid-August. And when it formed near the Bahamas, and it started to move towards South Florida. What I want to talk about is mesovortices and its eye. Andrew ended up landfalling with the same barometric pressure on Florida as Hurricane Brett landed on Texas. And I know George Bush during the time talked about how we need to pray for the victims. But it was not anything compared to Andrew in terms of damage, even though they had the same barometric pressure. And I realized it was a little bit more rural area, and you might have wobbled some cows. But there's quite a bit of evidence that the surface winds were a little bit higher, and the behavior of the winds were a little bit different. Andrew had 5 pentavortices, which are like a little bit like tornadoes rotating around the eye of the hurricane. So what's going on there? What's going on is water is a very, very powerful dielectric. What that means is that water has a hard time, or electric fields, electric currents have a much more difficult time. Magnetic fields have a difficult time going through water. And water ends up being the organizers of two kind of connected things. One is that it takes a lot of energy to compress air, and it takes a lot of energy to create a vacuum. And a vacuum and higher pressure areas will kind of annihilate each other. The same idea is true with static fields. Positive charges, it takes a lot of energy to put more and more positive charges into one place. It takes more and more energy to put negative energy and negative charges into one place. And when negative and positive charges get together, they essentially annihilate each other. So Andrew was very unique in that you have this eye area which you would consider to be free of water vapor, but in fact what's going on in the eye, particularly along the eye wall, the wall clouds, you have an area that's kind of a secondary area of fields where positive and negative charges organize, and where you get high and low pressures organizing with what little water is left that is phase changing from water to water ice. It's super cool water. It's the most carbonated part of a storm because the surface low is agitating the ocean and sucking into the clouds this carbonation. That there was a study on Hurricane Felix in 2001 that Harvard did with Bates et al., and they showed that 1/3 of the carbonation left the ocean as Felix passed by. Now you can imagine how much carbonation would have left the ocean with Andrew, which was a Category 5 storm. Now, in addition to carbonation in this storm, you also had SOx, or sulfur acid, that in addition to the carbonation, those aerosols became very involved with the cloud microphysics of Andrew and helped to lead to its unusual damage and mesovortices behavior as it plowed through South Florida and caused incredible amount of damage to structures and so forth. So you see this image here, And this image is very unique because it's an IR image from 1992, infrared, and it's showing basically where the ice crystals are, which is just this idea that it's showing hot because of it, or it's showing cold because of the cirrus clouds trapping the heat underneath the storm, and this is part of its dynamic and part of the organization that the electrical part of the storm is bringing on. What you see in the eye itself is what are the pentaforces, which is 5 separate, almost like tornadoes that are rotating around inside the eye. But what I want you to pay attention to is about how long the half wave of the inside part of the vortex is. So you get here, that's a little bit filled with cloud cover, the 2, 3, 4, 5. Now, what I want you to pay attention to next is Florida, which itself is shaped, is long, and it has definitely by itself has an antenna-like shape or feature to it in terms of how it's going to capture the area's electrical waves. But on top of it already having this shape, there's also the island chain that comes out of the bottom of it. And if you follow that island chain coming out of the bottom of Florida, you see undulations along that wedge of air. And first of all, it defies Coriolis, it defies any kind of normal shape that you would expect from surface winds and from a storm. It's kind of concaved there with the undulations, and it's most concaved, and the waves are clearly very straight, and there right next to is the island chain comes out, and then there's an echo of it behind that, and only undulations basically behind that island chain all have the same frequency of what you're seeing in the eye. So one thing to understand, land is about 5,000 times more conductive than saltwater ocean, especially warm saltwater ocean, which you had with Andrew. However, it is true that it wasn't over land very long at that point. It had just kind of gone over a bay, and so we're not talking about a very long time. And also the storm itself is going to put moisture on the surface there. But there's no doubt in my mind, it's my opinion, that when a tropical storm landfalls, the capacitive couplings that exist between the high pressure above it and the low pressure on the surface lose a lot of their charges. Now the storm itself was still over the ocean. It was still decarbonating. It was still bringing decarbonated air or carbonated air into the eye. But there was definitely some decoupling occurring. And those currents and those charges have to go somewhere. They're free. And if you look out that antenna, that's where they went. Clearly. You have undulations there. You have resonances that are occurring around and about the storm that are caused by lightning strikes, and basically they crescendo, and that crescendo then in ordered ways changes cloud microphysics, especially cloud microphysics that have a lot of carbonation in them, have a lot of sulfur acid, and have warm salt water all around, and very much organized by the water of the storm disk holding in those currents and charges and those couplings. But also within the eye itself, there's enough phase changing occurring so that you basically have 5 massive tornadoes rotating around and grinding everything on the surface. And that's where the damage occurred from Andrew. It had to do with a little bit different cloud microphysics in a storm from the global impact of what Pinatubo had on the Earth in terms of temperatures of oceans and in terms of what particles were in the air. Now, kind of thinking about that, then it really makes sense why sulfur-loving extremophiles are called, really, were such an important part of early Earth, because this gets to fundamental management of the Earth's magnetic field. And so you have the methanogens, which make methane hydrates, also important for managing carbonation, given rivers and their rivers' ability to act like antennas. And you had bacteria, which will convert methane into carbon dioxide as it gets to the surface, depending upon how the rivers are behaving and the feedbacks that are required. Okay, so that's my show on Hurricane Andrew. I hope you have a good one, and good luck. Thank you for watching. Please click the like button or join. Thank you. Oh, it's not clicking off.